Hello and welcome. In this video we're going to take a look at how we can add a React user interface to IdentityServer 6. Now over here on the left hand side I have an existing solution with a few projects in it, and I'll just walk you through those projects briefly now before we begin. So first of all, I have a project IdentityServer.bff, BFF being short for backend for front end, and this essentially is the backend of IdentityServer, the server-side part of the application. As you can see, I have a data folder with an application DB context. This is set up to extend from identity DB context with our custom application user type, and this is extending ASP.NET Core Identity. I then have a migrations folder, and I have migrations set up for the configuration DB context and the persisted grant DB context. Within the identity folder, I have our migrations for the application DB context, which stores the user data from ASP.NET Core Identity. Within the models folder, I have the application user model, and this extends the identity user from ASP.NET Core Identity, and we've added in a given name property and a family name property as an extension to the built-in properties with ASP.NET Core Identity. Next up, we have our appsettings.json and our appsettings.development.json. In the development app settings, I've added a connection string for the identity database, which stores our user data, and also the identity server database, which stores the identity server data. That's things like clients, API resources, API scopes, etc. So I've kept those two databases separate for the purposes of this sample. So the identity database containing our user data is separate from our identity server database, which contains things like clients, API resources, etc. I've then got our program startup logic. You can see that I'm adding in our application DB context. I'm then adding in ASP.NET Core Identity with the default token providers and also the entity framework store in order to store our user data in the database that's referred to in the add DB context. We're then adding in IdentityServer with its integration with ASP.NET Core Identity with our application user type. And I'm then setting up the DB context options for the configuration store and the operational store. Last up, inside our middleware, we are using routing and then using IdentityServer. And then just before we run the application, I'm making sure that the databases are migrated if we're running in the development environment. I'm then also adding in a default user, Thomas.Clark. I'm then making sure that we have a client for our sample web application. And I'm then adding in the OpenID profile and email identity resources all into the configuration tables of the IdentityServer database. And then last but not least, we are saying app.run in order to start the IdentityServer application. So that is our backend for front-end IdentityServer application. Pretty much what you get out of the box, fairly standard IdentityServer plus ASP.NET Core Identity. You'll notice then I've also got this sample web application, which is just a new Eraser Pages web application that is set up to use OpenID Connect authentication, talking to our identity server that we have running. And then last but not least, we have this project here, IdentityServer.UI. UI, of course, being short for user interface, and this is the front-end client-side part of IdentityServer. So the BFF is the back-end that lives server-side, and the UI is the front-end that lives client-side. So this is our React single-page application that we're going to use as the user interface for IdentityServer. The user interface including pages such as login, logout, etc. So you'll notice here this is just a file new React project. I've got the package.json set up with our React dependencies and also dev dependencies. I'm using ESBuild in order to build the React project, and I also have TypeScript set up so that I have a type support in the project. Inside the source folder, I have index.tsx, and this is just creating the root and then rendering our application into the HTML and JavaScript. Index.css just contains some basic styling. App.css is empty for the purposes of this sample, and then app.tsx currently just returns an empty component. So that is our IdentityServer.bff and IdentityServer.ui. Essentially, the BFF is just a new out-of-the-box Identity Server project with ASP.NET Core Identity, and the UI project is just a new React project that's set up with ESBuild in order to build the React application. So what we're going to do first and foremost is create some minimal API endpoints within our BFF project. That's because the UI, the React user interface, is going to need some API endpoints to call in the backend in order to do things like log in the user and log out the user. So what we're going to do first of all is right-click IdentityServer.bff. I'm going to add a new directory called handlers, like so. And inside here, I'm going to add a new class called account handler. And this account handler is going to contain our login method and our logout method, or our endpoints, as you might say. So the first thing that I'm going to do is create a public record called login input model, like so. And this is going to contain string username, string password. It's going to contain a nullable string for the return URL. And then we're going to say a bool is persistent, and we default that to false. Is persistent meaning whether or not the user will remain signed in after they have closed the browser window. So what we can now do is we can now say public static async, and this method is going to return a task of type iResult. And this will then be a login async, like so. And then inside here, what we're going to do is we're going to say from services, and this is going to be the Identity Server interaction service, like so. We're then going to want another service, and this is going to be iServer URLs, again coming from Identity Server. And then the last service that we're going to want is the sign-in manager. And that sign-in manager is going to be of our application user type that we defined previously. Refer to that as sign-in manager. And then last but not least, we can say from body. And then I'll say login input model, and I'll just call that input, like so. Now what we're going to want to do in here, first of all, is we're going to want to sanitize and validate the return URL from the body of the request. So what we're going to do is we're going to say var return URL equals input.return URL not equal to null. In other words, if the UI has provided a return URL in the request, then what we're going to do is we're going to say await interaction service dot get authorization context async, and you'll notice that this takes in a return URL. So this will be our input.return URL, and if that authorization context is not equal to null, then we can safely return the input.return URL because we have a valid authorization context for said return URL. Otherwise, if the return URL is null, i.e. it's not been passed in from the UI, or if there is not a current authorization context for that return URL, then we're simply going to return server URLs.base URL. And this is the base URL of our identity server. Alternatively, of course, you could return some other fallback URL that you want the UI to redirect to after the user has logged in successfully. For the purposes of this sample, we'll just return to the base URL of IdentityServer, but you might have some other page that you want to redirect the user back to if the return URL is either null or is invalid, but the user has still logged in successfully. Alternatively, of course, you may wish to return a bad request or some other error stating that the return URL is not valid. Again, that's entirely up to you, and you can do whatever you see reasonable for the purposes of your project. So now that we have that return URL, we can attempt to sign the user in. So for that, we can say var result equals await sign in manager dot password sign in async. And in here we can say input.username, input.password. And then you'll notice the third parameter there is the boolean is persistent. So we can say input.isPersistent. Again, is persistent, indicating whether or not the cookie should be persisted after the browser is closed. In other words, should the user remain signed in to IdentityServer after they've closed the browser and then come back again at a later date. And then last but not least, the logout on failure, we will set that to true. And that means that if a user logs in or attempts to log in with invalid credentials multiple times, then after X number of failed attempts, their account will be locked for a specific period of time. So we'll set that to true. Again, feel free to adjust those parameters as you see fit in your application. And then what we'll do last up is we will say return result.succeeded. Then we will say results.json. And we will simply pass the return URL back to the UI. Again, that will either be the return URL that the UI has passed into this endpoint, passed back to the UI, or in the case of the return URL being null or not valid, it will be the base URL of IdentityServer. Alternatively, if the result has not succeeded, i.e. the user has failed to sign in, then we can return results.badRequest. And then I will return the toString of the result, which will be the message indicating why the login attempt failed. For example, invalid credentials, two-factor authentication required, etc. Those are all defined in the sign-in result class. So that's our login method, essentially getting the return URL and validating to make sure that it is valid. We're then attempting to sign the user in using the username and password specified from the UI. And if the sign-in result is successful, then we are sending the return URL back to the UI because the UI will then be able to use that to redirect the browser. Alternatively, if the result is not successful, then we return a bad request to the front end, to the UI, and we indicate why the result was unsuccessful in the body of the response. So that is the login async method in our account handler, and we're now going to do similar but for the logout functionality. So what I'm going to do is create a record called logout input model, like so, and this will contain a nullable string called logout ID. And that is the identifier of the current logout that IdentityServer will pass to the UI, and the UI can then pass to this API endpoint when it sends a post request to log out the user. So what we can then do, similar to what we've got above, is we can say public static async task of type iResult, and we can call this method logout async, like so. And inside here, we're going to say from services, again, the IdentityServer interaction service, like so. And we're then going to also want from services, and we're going to want to inject the sign-in manager of type application user, much like we did above. And then finally, we can say from body, a logout input model, like so. I'll just call that input. And those are the parameters that we need for our logout async method. And then what we can do in here is we can say var request equals await interaction service dot get logout context async, and this will be input.logout ID, and this will be the logout request that the logout identifier refers to. What we can then do is we can say await sign in manager dot sign out async, like so, and then we can return results.json, and then inside here we can say iframe URL equals request dot sign out iframe URL, and the iframe URL is the URL of the iframe that should be rendered on the logout page in the UI in order to round trip the logout request. And then we can also say post logout redirect URI, like so, and this is going to be the request dot post logout redirect URI. And the post logout redirect URI is the URI or URL that the browser can redirect to in order to return the user to the application, for example. So you might specify when you sign out a logout redirect URI to return the user back to the application that they logged out from after they have seen the logout page within IdentityServer. And you could also set up custom logic on that logout page to automatically, for example, redirect the user back to that logout redirect URL, and that typically will be the URL or a URL for a page in the application that the user has come from in order to return them from IdentityServer back to the application that they came from after they have successfully logged out. So that is our logout async method, essentially getting the logout context for the logout ID, signing the user out using ASP.NET Core Identity's sign-in manager, and we're then passing the iframe URL back to the UI, the URL that the UI needs to render within an iframe, and then the post logout redirect URI, which is the URI that the user interface or the browser should redirect back to after the user has confirmed that they have logged out. So that is our account handler with methods there to log in and to log out. And what we're going to do now is wire up those two endpoints within our program startup. So if we come back into our program.c#, you'll notice underneath our var app equals builder.build, we have app.useRouting and app.useIdentityServer. What I'm going to do, just beneath app.useIdentityServer, I'm going to say app.mapPost, and this is going to be /API/login. And then in here, I'm going to say account handler.login async, like so. And then I'm going to do the exact same thing again. I'm going to say app.mapPost of /API/logout. And this is going to use the account handler.logout async method. And that has wired up those two methods in the account handler to our endpoints within startup. So if we navigate to /API/login, then that will trigger the login async method. And if we send a request to /API/logout, that will trigger the logout async method within our account handler. So that's the two API endpoints configured, one to log in and one to log out. And what we're going to do now is we're going to tell IdentityServer to use our React single page application as its user interface. Now out of the box, of course, you can get a Razor Pages user interface for IdentityServer. And in order to do that, you would simply say app.map_razorpages, as well as setting up the appropriate services further up in our program startup. However, we are not going to be using Razor Pages. We're going to be using our React single page application. And in order to do that, there's a couple of things that we just need to customize within our IdentityServer options. So you'll notice here we have builder.services.add_IdentityServer. And what we're going to do in here is we're going to say identity server options, like so. Just rename that to make it clear. And then what I'm going to do is say identity server options .user interaction .login URL, and that is going to equal /account/login. And then we're going to do the same thing again for the login return URL parameter. And we're going to specify that is return URL. Third, we're going to say user interaction .logout URL, and that's going to be /account/logout. And then we're going to say user interaction logout ID parameter equals logout ID. And those are the 4 properties that we're going to customize for the purposes of this sample. So we've set the login URL and the logout URL. We've also specified the query string parameter name for the return URL and also the logout ID parameters. And those are the keys, if you like, of the parameters as they would appear in the query string. Now again, there are several other URLs that you may wish to customize for your identity server. For example, the consent screens. I'm not going to go into adding the consent flow into our React single page application, but you'll be able to do exactly the same thing that we do with the login and logout URLs for all of the other pages that you may need within Identity Server. And this is where you can customize those URLs to match the routes that you define in your React single page application. So last up, underneath builder.build, we can say app.use static files, like so, and that will set up our backend to serve the static files that are built from the React single page application. And then underneath our 2 app.map posts, we can say app.map fallback, and we can say app.map fallback to file, and then we can say index.html. And what that does is it tells the ASP.NET Core web application if it doesn't find a matching route within the backend, in other words, /API/login and /API/logout, then it will send any unmatched paths to the file index.html. And the index.html file will be the built output from our React single page application. You'll notice inside the public folder of our React application, we have this index.html file, and that will be built and placed into the www.root folder within the built output for our identity server. And ASP.NET Core will then route any unmatched requests to that index.html file, and then within the index.html file, the React routing will then kick in to serve the React UI to match those particular routes that haven't been matched within the backend inside the BFF. So that is our backend now all set up with our login endpoint, our logout endpoint, our custom identity server options to provide the login URL, logout URL, and the query string parameters appropriately. And then we've also used the static files middleware and then mapped the fallback to index.html for any unmatched paths within our requests. So what I'll now do briefly, just before we move on to the React user interface, I will show you the Docker file that we're using to build the backend and the front end. So you'll notice here that we first of all start off building the backend project. So you can see here I'm pulling down the .NET SDK image as .NET. I'm setting the work directory to source. I'm then copying in the csproj file for the IdentityServer.bff, copying that from our local directory into the Docker image. I'm then running a .NET restore of that csproj file. After the restore is done, I'm then copying all files from IdentityServer.bff into the image, and I'm then running a publish with the release configuration, and I specified the output directory for the published output as /app/publish within the Docker image. So this takes advantage of Docker's caching, so it will copy just the CS_proj file into the image. It will then run a .NET restore using that CS_proj file, and this will then be cached for subsequent builds. So when we make a change inside one of the source files in the IdentityServer.bff project, it won't do a .NET restore each and every time. It will only do a .NET restore if we make a change to the CS_proj file, because that's the only file that we copy at this stage of the build. So that means that it will only run the .NET restore once unless we make a change to the CS_proj file, and so we're only going to ever be copying the BFF source files and then running a .NET publish repeatedly. So that saves a bit of time when it comes to building the backend for every time we make a change. And we then have this second block here which builds the front end. So you'll notice that I'm pulling down the latest long-term support image for Node as Node, setting the work directory to /source. I'm then copying in the package.json and the package lock.json, similar to what we're doing with the CS_proj file, but these of course are the front end equivalents, the package.json and package lock.json. And then cding into the UI directory and then running npm install. I'm then copying in all of our UI source files, and then I'm cding again into that UI folder and then running npm run build. And this again takes advantage of Docker's caching, whereby it will copy package.json and package lock.json and then run an npm install. Provided we don't then make any changes to package.json or package lock.json, it will only ever copy our UI source files and then do an npm run build. So we won't be running an npm install every time we do a Docker build unless we make a change to our dependencies or to any other lines of code inside the package.json or package lock.json. Provided we don't make changes to those, it will only ever copy the UI source files and then do an npm run build. Much the same as it does with our .NET equivalent, where we do our .NET publish. And then last but not least, we have the third step of the Docker file, the third image, if you like, that it builds. And this is using the ASP.NET Docker image as final, the final image in our Docker file. We're setting the work directory to /app. We're then exposing port 80 and port 443, as those are the HTTP and HTTPS ports. You'll then notice how we're copying from the .NET image, which is this image up here. We're copying the /app/publish directory, which you'll recall is where we specify the output artifacts to be published to. We're copying that directory to just the current directory, which is /app, because that's our work directory. And then from Node, which is our second Docker image here, we're copying source, UI build, and I'm just going to update that to IdentityServer.ui, like so, in order to match the path IdentityServer.ui. We're copying from /source/IdentityServer.ui/build, and we're copying that into our www root folder. So what we'll end up with is we'll end up with all of our .NET files, for example DLLs, etc., copied to the /app directory in our final image, and then we'll have all of our static single page application files copied to the www root folder within the /app directory, and that mirrors the directory structure that we would need in .NET for it to use the static file index.html as that fallback, because the static files middleware will automatically look in a folder called www root within the published output in order to search for static files. And then last but not least, we set up the entry point as .NET IdentityServer.bff.dll, and that will then run our application. So that's our Docker file going over there, how we build the back end, build the front end, and then combine the two together in a single final image, and then use the entry point .NET IdentityServer BFF.dll in order to then run our application. So what we can do now, in order just to verify that we have everything wired up and working correctly, we can now run that application. So what I'll do inside the terminal is I'll run docker compose up --build --detach. And what that will do is just take a few minutes there to pull down the .NET and Node images, and it will then build our applications using the Docker Compose file that I have defined in the root of the repository. So we can see there it's created our database. We're using a Postgres database to store our identity and identity server data. We have a volume for the database so that our data is persisted between Docker Compose up and down sessions. And we then have a container for Identity Server and a container for our Razor Pages web application. So what I can do, if I come here into our browser window, and if I go to HTTPS web application, and then port 7002 like so, you can see that I have here our ASP.NET Core Razor Pages web application. And what I'll do is I'll just open up the network tab like so. And if I hit sign in, give that a few moments to load. And that is going to now redirect off to Identity Server. And you'll notice that we're now redirected to Identity Server /account/login. And you'll notice that we just get served with an empty page because that's all we have currently in our React application. We don't have any routing. We just have a single app.tsx file which just returns an empty component. What this is useful though, just before we start our work in the React app, it's useful for verifying that we have set up Identity Server correctly and that it's correctly using the URL that we set up in the Identity Server options. You'll remember we called that URL /account/login, and then we've also got the return URL query string parameter that we specified as return URL. So that's a good bit of validation for us to confirm that we have our Identity Server options configured correctly. And what we can now do is make a start on adding in the user interface to our React single page application. So what I'll do for the moment is just minimize that. And over here in the React application, I'm going to create a new directory within source, and I'm going to call it pages, like so. Inside here, I'm going to create a TSX file, and I'm going to call it a login, like so. And this is going to be our login page. So what I'm going to do is, first of all, I'm going to import a React from React. And then I'm going to say export default function, and I'm going to call it login, like so. And for the moment, I'm just going to simply return an empty component, like so. Now, what we're going to want to do, first and foremost, is we're going to want to get that return URL from the search parameters. So in order to do that, what we can do is we can say const, and then we can open an array, and we can say const search params equals use search params, and that will be from the React router DOM, and that will give us access to the search parameters in the query string. And we're going to then use those search parameters in order to get, as I say, the return URL, in order to attach that into the body of the post request that we make to the login endpoint. You'll remember earlier on how we defined that optional string parameter return URL in the login input model. What we're going to now do is we're going to create a handler to handle the login form submit action. So what I'm going to do is I'm going to say const handle submit, and this is going to use a React callback like so. I'm simply going to specify an empty callback for now, and inside the dependencies, this is going to depend on these search parameters because we're going to make use of search parameters within this callback function. And inside the callback brackets, what we can do is we can say event, and the event is going to be of type form event, and the form event is going to be of type HTML form element, like so. And then within the body of this callback, we're going to want to say event.preventDefault, and this will prevent the default form behavior from taking effect, because we're going to override that now with our custom submission logic. So what I'm going to do is I'm going to say const form equals event.currentTarget, and this is going to be our HTML form element. What I can then do is say const form data equals new form data, and then I'll pass in the form like so. And then what I'm going to do is say const response equals await, and then we're going to send a fetch request into our backend. What I'll do is I'll make this callback async like so, and then inside the fetch we're going to send a request to /API/login. That is the login endpoint that we defined it with our app.map post in our program startup. So I'll say /API/login like so. And then inside the options to fetch, we're going to create a body, and this is going to be a JSON stringified object. And inside here we're going to say username, and this is going to be formData.get, and then this will be the username field. We're then going to say password, and that's going to be formData.get, and then password, like so. And then last but not least, we're going to say return URL, and that's going to be searchparams.get, and then return URL. And that will get the username and password from our form data of the submitted form, and then the return URL will be retrieved from the query string with the use search params hook from the React Router DOM package. What we can then do underneath body is we can say headers like so, and inside headers we're going to create a header called content type, and this is going to be application /JSON, and that tells our post request that we're using the JSON content type in our body. And then last but not least, we can say that the method is post, and that is then the request method that we're going to use, the HTTP method, for our fetch request. Otherwise, by default, fetch will use a get request unless we specify the method here in the fetch options. What we can then do is we can say if response OK. Then what we can do is we can say const curly braces return URL equals await, and then response.json, and that will convert the response body to JSON, and then we can pull out that return URL that you'll recall we return in the logout action in our account handler that we defined earlier on. We specified results.json and then the return URL if the sign-in is successful. Otherwise, if the response is not okay, for example, if the response is a bad request because the sign-in has failed, then we can say form.reset like so, and that will simply then reset the login form. Again, you may wish to, in that block of code, for example, display a modal or some sort of message saying that the login has failed. And then last but not least, with that return URL, we can then say window.location.href equals return URL. And that will then cause the browser to redirect to the return URL that we get in our response from the backend in that login action in our account handler. So that is the callback to handle our form submission. Essentially, we are saying event.preventDefault to prevent the default form submission behavior from taking effect. We're then retrieving the form element using event.currentTarget. We're then newing up our React form data using the form. And then we are sending that form data off in a fetch request to our /API/login endpoint with the username and password from the form and the return URL from the search params, which is from the query string. And then if the response is OK, in other words, we have a successful sign-in, then we are retrieving the return URL from the API's response and then redirecting the browser to that return URL. Otherwise, if the request is not successful, i.e. sign-in has failed, then we are resetting the login form in order to allow the user to try again with other credentials. And again, in that else block, as I said earlier, you may wish to add some custom logic to display some sort of login failure message in your application. So that is the logic defined to handle our form submission. And what we can now do is actually create the form itself. So whereas previously we were returning just an empty component, what we can do is we can return a form like so, and the onSubmit property of the form will be our handleSubmit method like so. And then within the form we can define a couple of inputs. So the first one is going to be an input for username. So we're going to say label HTML4 and then username like so. And this is going to be username. And then we're going to specify the input. And the input is going to have autocomplete set to a username. We're then going to specify the ID of this input to be username. The name will also be username, and it's important to note that the name property here of the input is what we can use to look up the value of the input when we do formData.get. So you'll notice here we're saying formData.get with a key of username, and that key corresponds to the name that we give to the input in our markup. So it's important to note there that the ID is used for the label and then the name is used for retrieving the value from the form data. We can then specify that this is required, and then we'll specify the type as just text like so. Then what we're going to do is we're going to create another input. This is going to be for the password. So we're going to say HTML4 and this will be password. And then once again, we will create an input. We give it an autocomplete of current password, like so. The ID will be password. Then the name will also be password, again corresponding to formData.get password that we've defined in our handleSubmit callback. We can then mark the password as required, and then we'll specify the type to be password. And then last but not least, we can create a button like so, and this will be our login button, and this will be of type submit. And it's this button that will then trigger the onSubmit of the form, which then calls the handleSubmit callback that we defined further up inside our component. So that's our form with our submit callback handler, with our username and password inputs and our submit login button. So that is our login page created, and what we're now going to do is create a page for logout. So what I'll do is right click pages, add a new TypeScript file. I'll select TypeScript JSX in order to make it a TSX file. I'll then call it a logout like so. And we can now create our logout page. So what I'll do is I'll start off by saying import React from React, and then I'll say export default function called logout, like so. And then what I'm going to do, much like we did at the top of our login component, I'm going to say const search params equals use search params like so, and that will give us access to the search parameters from the query string, courtesy of the use search params hook in the React Router DOM package. And then what we're going to do is we're going to define a few bits and pieces of state. So the first thing that we're going to do is we're going to say const iframe URL and then set iframe URL equals a use state, and that's going to be of type string. And then what we're going to do is we're going to say const loading and set loading, and that will be use state, and we'll pass in true as the initial value. And then last but not least, we can say const post logout redirect URI, and then set post logout redirect URI, and that's going to be use state of type string with no initial value, much like our iframe URL. And then what we can do is we can use the useEffect hook in React to make a fetch request in order to trigger the logout. So what we're going to do is we're going to say useEffect like so, and then the dependencies of the useEffect will be our search params, and then we're also going to have the set iframe URL, set loading, and then set post logout redirect URI as all of the dependencies that we'll be using within our useEffect function. So what we'll do within this useEffect is we will use the logout ID from the search parameters to send a post request to our logout endpoint in order to trigger the actual sign out behavior within the backend using that sign-in manager that we injected into the logout action in our account handler. So what we're going to do is we're going to say fetch like so, and we're going to say /API/logout because that was the path of our map post for the logout action. So we'll do that like so, and inside the options to the fetch we're going to create a body, and this is going to be JSON.stringify, and then we're going to say logout ID, and that's going to be search params.get and then logout ID. You'll recall how earlier on inside the IdentityServer options we defined the logout ID parameter to be called logout ID, and that is the key that we're using here to look up the logout ID from the query string. Again, if you used different IdentityServer options in the startup, in the BFF, then make sure you set the login return URL parameter and logout ID parameters appropriately in the login page and the logout page. Make sure that these values match what is defined within the IdentityServer options in the startup, just in case you have called it something different in your project. What we can then do is we can say headers, and we can say a content type, and this is going to be application/JSON like so. And then last but not least, we can specify the method as post. And that indicates that this is a post request. Again, fetch defaults to get if you don't specify a method. So we explicitly have to specify this is a post for our request to the API. And then what we're going to do is we're going to say then, and we'll say response like so. And if response.ok, then we're going to return response.json. In other words, if we get a successful response back from the API, then we are going to convert the body of the response as JSON. And then what we're going to do is we're going to say then again like so, and we can then pull out from the body the iframe URL and the post logout redirect URI. So what we can do is we can say iframe URL, and then we can say post logout redirect URI like so. Give that the default object just in case it's null. For example, if the response is unsuccessful, then we're not returning anything from the previous then callback. And what we can then do inside here is we can set the iframe URL to iframe URL, and then we can set post logout redirect URI to the post logout redirect URI, like so. And then last but not least, inside our finally, we can then have a callback here, like so, and we can then say set loading as false. And what that means is it will always set loading to false as the final step of the then callback chain. And even if an error is thrown partway through, it will always execute that finally last. And we can then use that to indicate that the request is complete, regardless of whether it was successful or not. We can set loading to be false, and then we can render the user interface. What you might want to do, for example, inside this then dealing with the response OK and converting the body to JSON, you might want to, for example, if the response is not OK, then you could say inside the else throw new error, and then you could say, for example, logout request unsuccessful, like so. Again, I'll leave that down to you. You might want to throw an error or display some, sort of custom message on the page. We'll just throw an error there, for example, saying that the logout request was unsuccessful. And then what we can do now, just beneath this use effect, is we can actually render the UI. So what we're going to do is we're going to say a return, and then if the request is loading, in other words, we're currently sending the logout request, then what I'm going to do is I'm going to simply return a p tag, and inside there I'll just say loading ... And otherwise, if the page has finished loading, then inside here I am going to render an h1, and inside here I'm going to say you are now logged out. And then what I'm going to do, if we have a post logout redirect URI, then I'm going to, inside a p tag, render a link to allow the user to navigate back to their application. So what I'll do is I'll say click here to return to the application, like so. And then the here, I will wrap that in an a href and then post logout redirect URI. So what that means is if we have that post logout redirect URI, then the user can click on that link there in order to be redirected back to the application that they came from now that they have logged out successfully. And then what we can also do is if we have an iframe URL, then we can render an iframe. So this will have a height of 0, like so. We'll also specify the source to be the iframe URL. And then finally, last but not least, we can set the width to 0. So that will render an iframe on the page with a width and height of 0 with the URL specified from IdentityServer in order to complete the end session request within IdentityServer. And that iframe is what is then rendered in order to round trip that sign out request, the end session, back to IdentityServer to complete the logout process. So that is our login page and our logout page defined within our React application. And what we can do now, last but not least, is wire up those two pages into our application. So if you now open up our app.tsx file, and you'll recall that we are currently just returning an empty component, just rendering nothing on the page. So what we're going to do inside here is we're going to say const router equals, and then we will say create browser router, like so. And this will then define the routes for our React application. So what we can do is we can define a path of /account/login, and this will then render our login component, like so. And then we can also define another route for logout. So this will be path/account/logout. And the element for this will be our logout page, like so. And what that means is if the user navigates to /account/login, it will render the login component. If they navigate to /account/logout, it will render the logout component. And then last but not least, inside the return, instead of returning an empty component, we can return a router provider, and we can specify the router of a router like so. And this then hooks up our React application with the React router DOM package in order to give our React application routing capabilities. Again, I've used React router DOM for this sample, but feel free to use an alternative router in your application, whatever router you see fit. And just one last point to note, these paths here, /account/login and /account/logout, these automatically align, or we've made these align with the routes that we define in the Identity Server options. So you'll notice the login URL is /account/login, which means that we have defined the path as /account/login in our React router. Important to note, those should both match, and if you change the login URL within the Identity Server options, then you need to change the logout path within the React router logic. And again, the same thing applies with logout. If you change the logout path in the Identity Server options, then you need to make sure that the path here inside the React router matches whatever you define in the Identity Server options, much like we did with the query string parameters for return URL and logout ID. So now that we have our React single page application created and set up with routing, I'm now going to reopen the terminal, and once again I'm going to run a docker compose up --build in order to rebuild the changes that we have made and spin those up inside our Docker Compose environment. We give it just a few moments there for it to run those applications. As you can see, it's recreating those containers now as we speak. And what we can then do once that's done is flick back into the browser and verify that has worked successfully. So if I come back here to the browser, I'll clear down the network and I'll navigate back to web application on port 7002, like so. And you'll notice that we're back to our Razor Pages file new boilerplate web application. And what I'll do now is I will hit sign in, like so. And you'll notice it takes a few moments there just to initial load. And you can see that we are redirected to Identity Server. So you'll notice in our requests, we are redirected to the /connect/authorize endpoint within Identity Server. And you'll notice in the request URL, we pass in details like the client ID, etc. And this then gives us a 302 response status code. And you'll see it's then redirecting us to /account/login. And that is because that is the path that we defined as the login path in the Identity Server options. So you'll notice we then have this request to /account/login with our return URL query string parameter set accordingly to /connect/authorize/callback. And that's because the flow essentially works whereby you start off in the Razor Pages web application. That will then redirect you to the authorize endpoint, which is the standard OpenID spec authorize endpoint within Identity Server. That in turn redirects you to the login page that you define as the login URL within the Identity Server options. And it's that URL that you have control over what the path is, for example, /account/login, with our return URL parameter set accordingly. What I'm then going to do inside the username is I'm going to enter the username and also the password for the seed user that I created during startup. And then what I'm going to do is hit login, like so. And you'll notice that I'm then redirected back to the web application. So what happens is I then hit login in the single page application in React. That then triggers the API request to log in. That will then actually sign me into IdentityServer and set the appropriate cookies for authentication. That will then come back to the React single page application as a successful response, and you'll then recall the logic we did in the login submission callback handler was to say if the response is successful, we then redirect back to the return URL. And you'll recall the return URL was /connect/authorize/callback. And that then triggers the IdentityServer middleware to handle the callback for authorization post-user login. In other words, after the user has logged in successfully, we then handle the callback to the authorize endpoint. IdentityServer middleware then runs to set any appropriate cookies and carry out any other necessary logic before then redirecting back to the web application. And that's something that you should note with the return URL that the React single page application gets. The return URL is actually returning back to /connect/authorize/callback within IdentityServer. And then IdentityServer handles the redirect from IdentityServer back to the web application. So you essentially have a three-step process, daisy-chained, when you are logging in. You start off in the web application, you then get redirected to IdentityServer. IdentityServer redirects you to the React single-page application user interface. That user interface then redirects after login back to IdentityServer in the backend, and then IdentityServer in the backend then redirects back to the web application. And that's the exact same flow as if you had the user interface in Razor Pages. In that instance, you have the web application redirecting to IdentityServer, which then redirects to the Razor Pages, and then you have the exact same thing in reverse. We've just switched out the Razor Page user interface with a React single page application user interface. And then what we can do, just to show the logout journey, if we hit sign out, you'll notice that we get redirected to the end session endpoint from IdentityServer. End session then redirects us to our logout page in React. That then triggers an API request to /API/logout. And that then comes back to the logout page with a successful response from the API. And you can then see that we have this request to connect end session callback, and that is triggered from the iframe. If we take a look at the payload for the logout request, you can see we send the logout ID to that API endpoint, and we then get back the iframe URL and the post logout redirect URI. You'll notice if we look at the elements inside our root div, you can see we have our "you are now logged out" header. We have our p tag with our link to return back to the application, and we then have our iframe with a 0 width and height, which then contains the source for the connect end session callback. So what that is doing there is it's going from the web application to the end session endpoint within IdentityServer in the backend. IdentityServer then redirects to the user interface, our React front end. Our React front end then sends the logout request to the API in order to get back the iframe URL and the post logout redirect URI if the logout ID is recognized. And provided that those both come back successfully to the React UI, it then renders an iframe, and the iframe then triggers the end session callback, which then signs you out of any other sessions that you might have active within IdentityServer. And we then have the post logout redirect URI, which the user can click on to then get redirected back to the web application that they came from. So it's a slightly different flow to the login journey, whereby you go from web application to identity server to React, then back to identity server, and then back to the web application. In the logout journey, you go from the web application to identity server to the logout page in React, and the React logout page then renders an invisible iframe which handles the round trip back to identity server, and the link that's in the page on the logout page itself redirects straight back to the web application without going via identity server. It's the invisible iframe that we render on the page in HTML that does the round tripping back to the identity server backend on our behalf. So that is how you can switch out the boilerplate Razor page user interface that's provided by Identity Server for a React single page application. For the purposes of this sample, I have simply created a login page and a logout page. Of course, there are many other flows, for example, the consent flow that you may need to create for your application. But certainly the bare bones minimal user interface that you need is just login and logout. And then of course you can extend that with additional pages based on your requirements. So just to summarize, we have our account handler in the backend for front-end project, which contains a login action and a logout action. That handles all of the logic to actually sign the user in, set the appropriate authentication and application cookies, and logout does the same thing in reverse, clearing down any authentication and application cookies that may have been set. We've then wired up our program startup with the appropriate options for Identity Server. We've then set up the static files middleware. We've mapped our couple of API endpoints for login and logout. We've then mapped the index.html fallback, so any unmatched routes will be redirected to our single page application index.html file. We then have our Docker file that does our backend build and our front-end build, and it then copies the build artifacts into the appropriate directories, the backend into just the /app directory, and the front end into the /app/www-root directory. www-root, of course, being where the static files middleware looks for static files in ASP.NET Core. And we then have our React user interface, which contains our login page with our simple login form, and our logout page, which then triggers a request to the logout endpoint in our API, and then renders the appropriate content on the page to allow the user to be navigated back to the application that they came from. And then last but not least, we have our app.tsx file, which contains our browser router with the /account/login and /account/logout paths for our login and logout components respectively. So I hope you found this video useful, showing you how you can use a React single page application as the user interface for Identity Server. You don't need to use Razor Pages, you can use any user interface you like, and that's one of the nice pieces of flexibility that Identity Server gives you. You can bring your own user interface in whichever framework you like, whether it's back-end, front-end, whatever. You're free to define that user interface as you see fit. So as I say, I hope you found this video useful. Thank you very much for watching, and I'll see you next time.